Okay, we're going to look at an introduction to hyperbolas. Hyperbolas. Well, the way hyperbolas work is they've got two branches. And I think actually what I might do is just go quickly back to this example here in the beginning. A very simple hyperbola would be y equals 6 over x. And then you just think, well, what kind of numbers could I put in for x to give this, to make these answers kind of easy? Well, if I put in 6, it would be good. 6 divided by 6 would be 1. 6 divided by 3 would be 2. 6 divided by 2 would be 3. And 6 divided by 1 would be 6. Now, if we put in the negative numbers, we'd get the same kind of answers. 6 divided by negative 6 would be negative 1. And when you graph them, you get these two branches. You see 1 and 6, 2 and 3, 3 and 2, 6 and 1, and the negative branch. You put in negative 6, negative 3, and hey, that's the base idea of a hyperbola. The x-axis, which is the line y equals 0, is one of the things called an asymptote. This line gets closer and closer, but it doesn't touch this asymptote here. This is called the vertical asymptote, and the equation would be x is always equal to 0. Now, a hyperbola has always got two asymptotes, and it often has x and y intercepts. But this parabola, it can't touch the x or y axis. It's got no x and y intercepts. Okay, let's take a look at a question here. Now, in grade 11, grade 10, we just looked at hyperbolas that kind of had a vertical asymptote of x equals 0. But in grade 11, it switches a bit here. If the number up here is positive, the shape will be in the first and the third quadrants. If it's negative, it'll be in the second and the fourth quadrant. But here's the easiest thing. I actually like to do this thing first. If y equals q, that gives you the horizontal asymptote for all these hyperbolas if it's in this form. And x equals the opposite of this number, x equals p. The opposite of this number gives you the vertical asymptote. If you let x equals 0, like all functions, and just put 0 in there, you'll get the y-intercept. And if you let y equals 0, you'll get the x-intercept. Let's take a look at a question. Okay, let's say x3 over x minus 3 minus 3 like that. Well, what's the shape? Oh, it must be in the first and third quadrant because this number is greater than 0. Now, I think the easiest thing is this horizontal asymptote. Y equals minus 3. And the vertical, so there's a horizontal line at y is always equal to 3. There's a vertical asymptote, the opposite of this, x equals positive 3. Now, if you graph those in there, so that's this vertical asymptote. I think it's good to start with that because it just makes it so easy. If you let x equals 0, just put 0 in there. 3 divided by negative 3 be negative 1 minus 3. Y is minus 4. Now, that's enough to sketch this thing. In fact, I want to show you right over here. You put in the vertical asymptote, y equals minus 3. You make your x and y axis. You put in the vertical asymptote. You put in the horizontal asymptote, x equals the opposite of this number. We put 0 in here, and we got minus 1, minus 3. We got minus 4. There it is. Well, it looks like this number might be 4. But there is a way to solve that last thing. If you let y equals 0, if we let y equal 0, then we multiply everything by the denominator. 0 times x minus 3, 3 times 3 over x minus 3 times x, it cancels, and you just get the 3. And this minus 3 gets multiplied by x minus 3. Well, there's minus 3 is 9. 3 plus 9 is 12. Put the 3x on this side, add 3x, divide by 3. Hey, we get that x equals 4. So we let y equals 0 to get the x-intercept, x equals 0 to get the y-intercept. There's your asymptotes. And the only thing you have to do, this might be called a function, f of x equals this. You should, you kind of need to label this thing. So if it was in this form, you might write the formula right beside it. Also, put little arrows on the end of these. Might be a little bit better than the way I show in this graph, but that's it. That's how you sketch hyperbolas, and I think they're pretty easy once you figure them out. I hope this helps. Okay.